In today's video, we'll be going over polar coordinates. Well, there are two main base equations that you must remember when dealing with polar coordinates. Those being x equals r times cosine of theta and y equals r sine of theta. So you can think of cosine to equal x and sine to be equal to y. The second thing you must remember is that whenever you see a polar coordinate, you're going to see it in the form of r, comma, theta. So that should give you an understanding of how you get from your coordinate to your equation. Besides the base equation and the coordinate system, there's also one more thing you must remember, which is whenever you are going counterclockwise, you are going in the positive direction when dealing with polar coordinates, whereas when you're going clockwise, CW clockwise, you're going negative. And if you know how a clock works, a clock usually goes like this. So that means this is negative, but then if you go from here, this is positive. Positive and negative. Well, now let's go ahead and do some practice problems. Well, we can see the first practice problem we have is asking us to convert our polar coordinates we can see here to Cartesian coordinates. Also, we're given that the first step is to plot our points and then to convert them into Cartesian coordinates. And number one says plot, and we're going to be plotting this on a specialized polar coordinate graph. So if we go below, we can look at our first problem, which is 5, 7, 5, or 6. As we said above at the beginning of the video, we know that polar coordinates are listed as r, theta. And when converting to Cartesian coordinates, we're going to be using the equations we also listed at the beginning of the video, which were r cosine of theta equals x and r sine of theta equals y. Well, if we note what our points are in our coordinate, we can easily figure out our equations. So we know the first coordinate is our x and this is our y. And if we also remember and apply this knowledge, we know this is r, or the radius of our circle, and this is theta. And you might be wondering, what is this r coming from and where is it coming from? Well, if we look at our polar coordinate graph, we can see that there's several circles, such as this one right here, etc. You can see there's several circles. Well, we can see this graph has a total of 1, 2, 3, 4, 5, 6, 7, meaning this whole circle or this whole graph has a radius of 7. Let's go back to our question, and we can see that we have a radius of 5. So as a radius of 5, so we're going to be 5 circles out. So here's the first one, second, third, fourth, fifth. So we're going to be in this fifth one. And remember, if we said that counterclockwise is going to be this way is positive, and this way is negative. So we can move this off to the side, and now let's go ahead and convert our points. Well, we also know that x equals r cosine of theta and y equals r sine of theta. Now, we know that theta is 7, 5, or 6, and we know r is 5. So let's go ahead and substitute those values into our equation. So we have a 5 times cosine of 7 pi over 6. And then I'll substitute into our y value, which is r, which is 5, times sine of theta. And we know theta from our coordinate point is 7 pi over 6. And now we're just going to use our unit circle in order to find the cosine and sine of 7 pi over 6. Let's go ahead and pull up our unit circle right here. And we know that 7 pi over 6 is right here. And the sine, well, we know sine equals y and cosine equals x. Well, we know that x, or cosine, is negative square root of 3 over 2. So let's go ahead and substitute that in. So we have 5 times the negative square root of 3 over 2. Then for y, we have sine of 7 pi over 6. Well, the sine, we said, is the y value, and the y value is negative 1/2. So we can go ahead and substitute that in. So 5 times negative 1/2. Let's go ahead and multiply. So here we would get negative 5 square root of 3 over 2. And for our y value, we would get negative 5 over 2. So that is our Cartesian coordinate. Let's go ahead and write that in coordinate form. We have negative 5 square root of 3 over 2, comma, negative 5 over 2. And since that was just problem 1, we can move it off to the side. And now we're going to do step 1, We're going to work backwards on this one. We're going to go back to step 1, and now we need to plot it on our graph. Well, let's go ahead and erase these extra markings. Well, whenever we're going right on our x-axis, so let's mark our x-axis in red. And so on this line, what we're going to do is we're going to say that everything to the right on our x-axis, so everything on our x-axis to the right, so every point, like 1, 2, 3, 4, 5, 6, 7, 8, whatever, they're all positive. Everything to the left, so let's just say -1, -2, -3, -4, these are all negative. So these are the things you need to remember for this part when graphing. Let's go ahead and graph the coordinate point. Well, we know our coordinate point is 5, 7 pi over 6, and we said each circle represents 1 radius. So each time we go a circle, that's 1, second circle, 2, etc. So we're going to go 5 circles out. So we know that this is our first circle, this is our second, third, fourth, and fifth. This blue line is our fifth circle. So now we need to go ahead and figure out how we can plot this theta value of 7 pi over 6. Well, we can see that 7 pi over 6, we have a positive theta value, meaning that we are going counterclockwise. Well, now we're going to be going this way because that is where counterclockwise is. And since we have to go 7 pi over 6, we're going to go 7 pi over 6 from our 0 mark up. And we can see from our polar coordinate graph that 7 pi over 6 is right here. So we went from 0 and we traveled all the way in the counterclockwise direction to 7 pi over 6. So that's going to be our first point. We can just label it for letter 1. And so we're going to go in a counterclockwise direction and we're going to get to 7 pi over 6. And we said it's on the 5th radius. And we said the 5th radius is this blue line on our graph. And this is 7 pi over 6. And that is for question number 1. So we can just denote it with the number 1. So now let's go ahead and do problem 2. Problem 2, we're doing the same thing where we're going from polar to Cartesian coordinates. Well, in this question, let's go ahead and graph it first because we can see there's one big difference. We have a negative radius. So negative radius, we said, when we're going left, we're getting negative on the x-axis. So we go 1, 2, and now we're at -2 for our radius because we went 2 to the left, which is the second circle. So now we need to go a total of pi over 6 radians. Well, pi over 6, so we're going counterclockwise. Counterclockwise is this way. So now we need to find where pi over 6 is. Well, if you remember, we have -2, so that's the second circle to our left, which we have denoted with this dot. And now we have to go pi over 6 in the positive direction, and we said positive is going to be counterclockwise. Well, we're at pi, so we have pi, and we have to add pi over 6. Now we need a common denominator, multiply pi by 6, so we have 6 pi over 6 plus pi over 6. That's going to be where we end up. So 6 pi plus pi is 7 pi, and our denominator stays the same, so 7 pi over 6. So we go from here to 7 pi over 6, and here we are at 7 pi over 6. So our actual point for problem number 2, we're going to follow the second circle to pi over 6, which is right here. So number 2 is right there. And that's how we would plot number 2. So now, in order to get the Cartesian coordinate, what we're going to do is follow the same steps we did in number 1. Now that we've plotted our point, we can go ahead and try to find the Cartesian coordinate. Well, if you look at problem number 1, we used our base equation, which was x equals r cosine theta and y equals r sine theta in order to find the Cartesian coordinate. We're going to apply the same logic here. We remember the first point represents our r, or our radius, and the second part represents our theta. Well, now what we need to do is substitute into this equation. So you have x equals r cosine of theta and y equals r sine of theta. Well, we know r is 2, so we can do it. Let's do x first, which is x equals -2 cosine. We know theta is going to be our y value, which is pi over 6. So cosine of pi over 6. Now we can go ahead to our unit circle and say, what is the cosine of pi over 6? We said cosine is our x value. So we'll add pi over 6, which is right here, our x value is square root of 3 over 2. So we have -2 times the square root of 3 over 2. That leaves us with -2 square roots of 3 over 2. 2 over 2 goes to 1, so we have negative square root of 3. So that is going to be our x coordinate. So let's go ahead and write that up here. So we so far have the negative square root of 3, comma. Now we need to find our y value. Well, for the y value, we're going to use our second equation, which is y equals r sine of theta. So we have y equals, we said our r was -2 according to our coordinate points. We have -2 times sine of our theta. We said theta is pi over 6. Sine of theta. We know sine equals the y value, and here's pi over 6 right here, and the y value pi over 6 right here is 1/2. So we have y equals -2 times 1/2. That is just -2/2, which is just -1. So our y value is -1. This means that the Cartesian coordinate for -2 comma pi over 6 is -3 comma -1. Now let's go ahead and do problem number 3, which is 3 comma 7 pi over 4, and that is the polar coordinate. So we can go ahead and graph that on the polar graph. So we know our radius is 3, so we're going to go to the third circle. So let's go ahead and find the third circle. So that is 1, that's 1, that's 2, and that is 3. That's the third circle we have. Then we need to go to 7 pi over 4. This is positive. We said positive is counterclockwise. Counterclockwise is this way. Well, if we start here, we're going to go 7 pi over 4. So we're going to go from 0 to 7 pi over 4. 0 plus 7 pi over 4 equals 7 pi over 4. So let's go ahead and do that. And we can see that 7 pi over 4 is all the way right here. So we're going to go all the way around to this part. And we're going to be in the third circle. So we're going to follow this third circle all the way around. And then finally, we're right here at 7 pi over 4. So this means that problem number 3 is going to be plotted right here at the radius of 3, because you can see we went 1, 2, and then we're in our third circle, and then we're going to 7 pi over 4. Well, now let's go ahead and convert this into a Cartesian coordinate. Well, if you remember, we're going to do the same thing we just did in the last two. So we have x equals our cosine of theta, and y equals our sine of theta. Well, we know r is going to be 3, and theta is going to be 7 pi over 4. So we have 3 cosine of 7 pi over 4. Let's go back to our unit circle. We know that 7 pi over 4 is right here, and we need to find the cosine. We said cosine is the x value. Well, we can see that the cosine, or the x value at 7 pi over 4, is square root of 2 over 2. Let's go ahead and write that. So we have 3 times the square root of 2 over 2. So we have 3 square roots of 2 over 2. So that is our x value. Let's go ahead and write that down. 3 square roots of 2 over 2, comma. Let's find our y value. Well, we know r is still 3, based on our coordinate point. Then times sine at 7 pi over 4. Well, sine is our y value. And if you look for our y value at 7 pi over 4, it is negative square root of 2 over 2. And let's go ahead and substitute that in. So we have 3 times the negative square root of 2 over 2, which is negative 3 square roots of 2 over 2. That is our y coordinate, so let's go ahead and write that down. Negative 3 square roots of 2 over 2. And then this is going to be our last Cartesian coordinate point for this type of problem. Next, we're going to be doing conversions from Cartesian coordinates to polar coordinates. Well, now, there are 2 more equations we need to remember. Those being r equals the square root of x squared plus y squared, as well as tan of theta equals y over x. Now let's go ahead and apply these equations to Cartesian to polar coordinates. Now let's go ahead and apply these equations to our conversion from Cartesian to polar coordinates. Okay, well, the first one we have is 5 comma 4 square roots of 3. Well, if we remember, we said that r equals x squared plus y squared. Well, we know our x is 5 and our y is 4 square roots of 3. Let's go ahead and substitute that into our equation. Let's go write it down here. So we have r equals the square root of x squared plus y squared. We know our x squared is 5 and our y squared is 4 square roots of 3. So we have the square root of 5 squared plus 4 square roots of 3 squared. Well, we know that inside our square root, we should get 25 plus 48. 25 plus 48 is 73. So we have the square root of 73. And now we know that this is our radius. If If you remember, the base for a polar coordinate is r comma theta, and we just said r is equal to the square root of x squared plus y squared. We just solve for r. We know r equals square root of 3, meaning that this is going to be our x-coordinate for polar. We said it's the square root of 73. Now we need to go ahead and find our y-coordinate. Well, if you remember, we just said theta equals our y-coordinate, and we can see our second equation has theta in it, which is tan of theta equals y over x. Well, if you rearrange this equation, we should get theta equals tan inverse of y over x. Well, if we use this in each of our questions, we'll be able to find our y-coordinate, also known as theta. Well, now let's go ahead and do that. So we have theta equals tan inverse of y over x. We also must remember that our answer for theta must be in radians. And simply, if you get a degrees, let's say we get 26 degrees, whenever you have a degrees, you're going to multiply by pi over 180. So simply it'll just be 26 pi over 180. Now let's go ahead and find our y-coordinate. So we're going to do tan inverse of y over x. We said our y is 4 square roots of 3 and our x is 5. And we take the tan inverse of this. This is going to equal theta. Theta is our y value for a polar. And now let's go ahead and solve for theta. And we should get theta equals 54.1825. And that's in degrees. So we just said that we're going to multiply by pi and divide by 180 if we want it in radians. So we're going to have theta equals 54. I'm just going to say 18 times pi over 180. And this is going to be our y value for our first coordinate point. So we're going to do 54.18 pi over 180. And that is our answer for number 1. Now let's go ahead and do number 2. Well, number 2 says 5, 2. We're going to apply the same logic we just did for number 1. So we have r equals square root of x squared plus y squared. We can see that x is 5, y is 2. So this is a much simpler problem. We're not dealing with the square roots. So now we have r equals square root of 5 squared plus 2 squared. We know 5 squared is 25, so we have 25. And we know 2 squared is 4. The square root of that. 25 plus 4 is 29. We take the square root of 29, and we know that equals r. So now we know r equals 29. We said r equals our x-coordinate. So now we know our x-coordinate is the square root of 29. Now to find our y-coordinate, we're going to do tan inverse of y over x, and this equals theta. Theta is our y value. So now we do y over x. We said y is 2, so we have tan inverse of 2 over our x value, which is 5. Now if we solve for theta, we get 21.8014. I'm going to call that 21.80. Remember, we want it in radians. We multiply by pi over 180. So we should get 21.80 pi over 180 for our theta. And this is our y-coordinate. Let's go ahead and put that into our coordinates. We have 21.80 pi over 180. We have one more question for this video, which is going to be question number 3, which says -3, 3. This one we are dealing with a negative. Now we have r equals x squared plus y squared. So the same equation we've been using, x squared. So x is this and this is y. So we have the square root of -3 squared plus 3 squared. So we have the square root of 9 plus 9 because a negative squared is positive. So we have 9 plus 9. 9 plus 9 is 18. So we have the square root of 18 equals r. R is our x value. So we have the square root of 18. Now let's go ahead and solve for our y value. We said theta, also known as our y value, is going to equal tan inverse of y over x. Well, we know our y value is 3, so we have 3 over our x value of -3. We take the tan inverse of this, and we get theta equals -45. And if you remember, in our unit circle, we know that 45 is pi over 4. If it's negative, it's just -pi over 4. We want it in radians. We can say it's just -pi over 4 for our y value, since we did get theta equals -45. If we want an explanation on that, if we go up 45, we reach pi over 4 in degrees, right? And if we go down 45, we're going to reach 315 degrees. 7 pi over 4 is also known as negative pi over 4. And since that is that, we can say our y value is negative pi over 4. If you believe this video helped, please consider to like and subscribe, comment for future video recommendations, and turn on bell notifications for future video updates. We have made an Instagram, and you'll also find updates for videos, and you can also DM me for video requests on there. We have passed over 100 subscribers. Thank you guys so much for all your support. I really do appreciate it. Thank you.